Hello, my name's Andy Swift. I'm part of a group called SAS. There's two other colleagues of mine in the actual group, which is Simon and Stephen. SAS is just the first character of our names. That's how we came to decide upon the SAS. We're here to discuss and talk about the network that we have designed. As you can see on the board, this is our network design, which is a wireless area network with DHCP. First of all, we have got a router with PS Sense installed onto it. We have got one switch which is on the local area network and another switch which is on the wireless area network. These are all connected cabled to the actual router. From the local area network switch, you have got a virtual machine with Windows Server 2008, and going on to the side of the diagram from the wireless local area network, we have got an access point. The access point is connected via the switch, and this enables mobile devices to be connected to the network through DCHP. Once a mobile device is connected, it is given a unique IP address via the wireless network and access point. Now will hand you over to Stephen for his part of the presentation, and he will be discussing the virtual machine. Thank you.
Right, I'm Stephen. I'm going to talk about the virtual machine and the operating system on it, which is the Windows Server 2008. The Windows Server allows us to add users to the network so they can log in then through the access point, as you can see here. Once a connection is created between the access point and the Windows Server through a shared secret, and the IP address of the access point will be added in the Windows Server, so they can then connection is established between them both. If a user wanted to connect to the access point, they would search for available wireless connections and look in the list for SAS. As Andy mentioned before, that is a group with our name. Once they've found the SAS, they'd be presented with a login screen where they would enter the user credentials, which have been created through the directory, the user settings through Windows Server. Once they're connected, they will be assigned an IP address, which then will be displayed in Windows Server. That will display a list of who's connected, what device they're using, and what IP address they have. Once they're fully connected, they'll then have a connection, and will be able to access the wide area network through the router, and then they will be able to connect to the internet and the outside world. Then they can browse websites, browse videos and whatever. Right, I'm now going to pass you over to Simon, who's going to talk about the router and the PF Sense side of the network.
Hello, my name's Simon, and I'd like to explain to you now the final part of our network, which was the PF Sense router, and how this works for the entire network. So as you can see, we have three interfaces that go into and out of the PF Sense router. As you can see on the left hand side, we've got interface 0, which is our LAN network. So this will be the virtual machine software that we've used, and with this we've got the Windows Server 2008. On the right hand side, we've got interface 2, which is our wireless LAN. So our access point will be connected to this interface. And finally, we've got interface 1 at the top, which is our WAN network, which is basically our internet access to allow clients to access the internet from inside our network. So now I'll just explain briefly what we've used with pfSense and how we decided to incorporate certain features that we've included. So the first part I'd like to talk to you about is how the IP addresses are issued. As you can see on the diagram, we've got specific IP addresses for sections of the network. The connections that come out of the router, these are our default IP addresses. So you can see on the left hand side we've got 192.168.71/24, and on the right hand side we've got 192.168.11/24. So we separated these two parts of the network, and by doing this we're able to configure the firewall settings, which I'll explain in a minute how we've done that. We've used static IP addresses for this part of the network. This is simply so that when the virtual machine and the access point connect to the network, they've always got their own unique IP address. This is a must-have feature for our network because of the way that the access point has to be able to talk to the Windows server when authenticating users. As Stephen mentioned earlier about the way that a user would log onto our network, there's a there's a secret key that's used, and in order for the server to receive requests from the access point, it needs to know the address of where the access point is located, and so forth. As with the Windows server, the access point needs to know where the IP address is so that it can send that information correctly. What we did was, when a client is actually able to connect to our network, instead of assigning a static IP address, they're given a DCHP address, so it's a dynamic IP address. The reason why we've done this is just simply to allow each device to have its own IP address, and then this rules out any possibilities of any collisions, especially if two devices try and connect and they're automatically given the same IP address. What we've done for the interface 1, however, is slightly different. Because we have no control over the internet access and there is a separate router outside of our control, we simply allow it to connect with a DCHP address. So the router would ask the internet to assign it an IP address so that it could access the internet. So in theory we haven't configured anything for this side. However, through pfSense we've created a allow dynamic address to be assigned. So I've explained how the interfaces all connect. I'll now explain briefly what we've done to incorporate security into our network. So the first one I'll talk about is the firewall. Obviously the firewall is important when you're looking at this sort of network, because you need to be able to filter and monitor what sort of traffic is going in and out of the network. This is especially important, especially if you've got devices that may be authenticated, however they might be using software that you may not want them to use on the network. So for instance, we've created a rule that would block any form of pinging on the network. So for instance, if a laptop was connected through the access point, at this point it'd have full access to the network, however we would not want them to be pinging the Windows Server machine. So by creating this firewall rule, we've denied access for the pings. This goes both ways as well, so the Windows machine will not be able to ping any of the client-side machines, and this was simply created with the firewall rule, which was to block this connection. So for instance, if a device issues a ping command to this IP address down here, 192.168.7.10, what would happen was the request would be sent through to the router, and once it reached the router, the firewall would pick up at this rule to say obviously pinging is blocked, and it would simply reject the continuation of the packets of data. So that way we've separated what the devices can and cannot do. Another feature that we've incorporated as well for the security is the websites that users are able to view. We've done this through filtering, so in essence what we've done is we've created a list of websites that we can either allow or disallow access to. In our case we used the example of Facebook.com just so that devices could not connect to this website. So it's a similar setup to create a firewall rule, except it's used with IP lists. So you'd have to know the specific IP addresses that Facebook uses, and then once you have these information, you would create a small text file which would have a list of the IP addresses on. And then once you incorporate this and switched on the IP filtering, this would then block Facebook from being accessed. Again, it's the same sort of process as how a pinging was blocked. So the user would type in facebook.com, for instance, onto their net browser. The request would get sent through to the router. Then our firewall program the IP blocker that was used would intercept, and at this point it would reject any further communication going out to the internet. Obviously, apart from Facebook, they're able to access other websites if they need to, as long as they're not blocked on our IP list. And yeah, that's how our network's configured. I'd like to thank you for watching today, and yeah, thanks very much.